Hello, everyone, and welcome back to our podcast, the M&E Drop-In. Today we have a very special guest, Mr. Paul McSoley. Thank you for joining us today. I'm really excited to talk to you today. We'll be talking about generally the new regulations, construction products, and workmanship. And Paul is an expert on these topics. So I'll let you introduce yourself. Tell me about yourself, Paul.
Thanks, Moj. Much appreciated. And thanks for having us as well. It's always a pleasure to get invited to do these things. I'm probably following in the footsteps of some other great people here with this. So hopefully we get this good today. So look, I've been in the industry for probably about 29 years now. I've not always been on construction sites at the beginning because I did an apprenticeship. I was probably lucky to have gone through that route because you get to see how things are installed and you realise, how hard it is to do it, because it's not just always about how things are designed, it's about putting them into place as well. So I've had many different roles over the years. I've worked in development. I've worked for some great big building companies as well, from Canary Wharf, Mace, Langeroog. I've been through several of them, and it's been really good experience. And yeah, I think you get to the point now in your career where you go, it's good to give it back, really, what you know, and hopefully we give, what's just an honest opinion of what we've seen, actually, to the benefit of everybody else. So,
Lovely. Thank you so much. Okay, so let's just dive into it, I guess. So when it comes to the regulations, and specifically the Building Safety Act, obviously this didn't just come out of nowhere. There's been many different regulations in the past. And how do you think people can get a proper grasp on these regulations now without first looking at the previous ones? What's the relevance of them? How has it kind of come to this point?
Well, there's a few questions.
Okay,
there.
sorry. Yeah,
no, it's all good. I'll try and break them out one by one, really. No, it's a good thing. Don't get me wrong. I mean, look, you've obviously got the Building Safety Act that's coming. There's lots of different secondary legislation coming out as well. And I think when you look at it, you go, this hasn't come about by chance. There's been some very terrible things that have happened to drive change that's required. But a lot of these regulations that were there previously are just being reinforced by it, if that makes sense. This is how I'm seeing things. And maybe not everyone sees it the same as me, but this is how I'm looking at it. And I think we've always had a duty under the original building regulations from as far back as I can remember, going back to when I was working at Canary Wharf, because we were dealing with this hands-on as a business then, because we had some of the biggest buildings in Europe at the time. We had some really fantastic people working with local authorities to get what was the safest solution for those plots. So you look at it and you go, we've always had a responsibility to make sure that buildings are reasonably safe to people in and amongst them, which is Regulation 8, and to those who are affected by them. Yeah. And that really isn't changing. I think when you look at the new Act, those kind of words are used a lot as well if you go through it all. But I think if you don't really have a grasp of what reasonable is, and it leads to other things, other regulations that are in there, you may know some of them. I think Regulation 7 is probably one you may be aware of. It's very hard to judge what workmanship and good material choices or what good products are unless you've been through that kind of mill originally, if that makes sense.
Yes, you mentioned Regulation 7. Let me just read it out really quickly. So Regulation 7 of the Building Regulations 2010 says, building work shall be carried out with adequate and proper materials which are appropriate for the circumstances in which they are used, are adequately mixed or prepared, and are applied, used or fixed so as adequately to perform the functions for which they are designed and in a workmanlike manner. So, first of all, what do we mean by workmanlike manner, and what's an appropriate system, in your opinion?
I think these are all really good questions. I think if we look at reasonable, then you apply reasonable to Regulation 7, because I think there's many different dynamics being said there. And I think one of the hard things, I think, for everyone, and in me included with this, is sometimes taking those wording and put it into practicable terms, what it means in practice. Yeah. So you sit there and you go, if things have got to be reasonably safe for people in amongst buildings, then you could say the ventilation system should be safe. The air you breathe has got to be okay. Can't be toxic. And if you use certain facilities and you flush things away, they go somewhere in a safe manner. And the systems that carry them are safe to carry them, because there's different hazardous risks in those systems when you dispose of certain waste. So when you look at Regulation 7, if you think about it, it's saying adequate and proper materials. So is the material adequate and proper to dispose of that waste? Is it adequate and proper to get the fresh air in? Is it filtered properly? Is it adequately filtered? Is it adequate to do that function? So you look at it and you go, the workmanlike manner is the installation part of it, but the first part really is how do you get to the appropriate product that's adequate for the function, I think it says for which it is designed. So you say, if you're in a lab where you need very good, or even in a hospital where you need very good clean air, which has got no pathogens in it, you need certain levels of filtration. That's going to have an adequate product that's been tested for that function. Then all you've got to do is install it appropriately, if that makes sense. And that's really, I think, the intent of what it's saying, and that really hasn't changed. I think the hard bit is that because we go right back, and the first time I dealt with that was probably about 1999, the first recollection of Regulation 7, when I first went from being an apprentice, and I remember my former boss told me when I went into construction, now welcome to the real world of work, and it was a big step change in mentality to go from being on tools and installing things to actually making sure what you're installing is correct. And the thing is always, why am I putting it there? Is it doing that function? Because no good just having something given to you and you say, well, I've just got to put it there. We need to ask ourselves, is it actually adequate? And I think that's the responsibility it's asking you to do. And that's been reinforced, I think, in the regulations now around safe products, which is general safe, and safety critical, which there's not really a list for, but I think we're going to work that one out in due course, if that makes sense.
Yeah. So you keep using the word reinforced. What do you mean by that?
Okay, I think the best way I can probably describe it is that if we look at things like, I'm going to use fire dampers, because if I didn't, everyone that listens to this would be disappointed, I think, as well, because it's always about fire dampers. Okay. There's many different products, the smoke control products, there's fire dampers, there's resistant ducts, and I'm lucky in the industry that I've got some very good people who are very knowledgeable on this. I'm able to feast off of their knowledge as well. I'm a summation of them as well, if that makes sense. So there's really good people. So when you look at these things like fire dampers as a good example, is that if we go back before construction product regulations, because I'm going to put that one on the table now as well, there was British standards for how you could test products. And the problem was with this originally was that you could test many different products which now have designated European standards, which are now British standards: fire dampers, smoke control ducts, smoke control dampers, you've got flues, there's loads, or chimneys is what they're called, but there's loads of these different designated standards, whereas before everything was running a BS test in a furnace. And back then you'd find that test didn't really have specific rules. So if we look at it and we say a pipe carries fluid, but a duct in a wall is dealing with ventilation and energy, because it's about the amount of energy it takes to push the air through it. What these regulations are doing is saying, well, because we're using the European test standards now, not the old British standards one for lots of these parts, though all the British standards haven't completely gone for everything, but they are being really phased out, and quite hard, I think, at the moment. We're in the situation that it's reinforcing the fact that if you choose one of these products, you can't just go, well, actually, this is a fire safety issue. It's actually, what is it functionally supposed to do originally? If it's a fire damper, as I said, it's got to do air as well. And these things have different operational, so some might be motorised, some might be fusible link that they shut. It's reinforcing the fact you've got to understand, if you look at appropriate for the circumstance, adequately prepared and mixed, that is the right product to meet the category of risk that where you're putting it. Yeah. And it's not just about the fire element, because you're protecting one side to the other with a damper, even with a pipe seal. It's actually about, does it do its original function, which is, I suppose, a Regulation 4 thing originally, Schedule 1. Is it doing Part F and Part L correctly? Then does it do the fire element? And then can it work with all the other products that are in the wall? So the wall's got its own product standard as well, its own products test standard, and its own classification. So that's all got to be compatible. Someone's got to work their way through that, and the regulations is reinforcing that you've got to do those checks, if that makes sense. It's hard because I don't think any one person has the knowledge of all the products to go, I know all the risk in the space, I know all the products that are going in there. In my mind, I need this wall, this thickness, this type, and these products to meet it all. There's a lot of actors involved to get there, and there's a bit of a reinforcement about making sure everyone's got the, as we mentioned previously with CPA here, is that you've got to have the competency to understand how it's designed, then have the competence to put it in, if that makes sense.
So is that what you mean by an appropriate system? Is that we don't just look at the product individually, but as what you're going to use it with, basically, and there has to be evidence behind that whole system.
Yeah, and it is really confusing because I think you look at it and we've been so used to, I think, just putting stuff in walls originally, and someone comes in with the magic ablative bats and mastic guns and it's all fine. But actually, when you take your step back from it and you say, well, to do it, you've really got to understand that, like we talked about, this reasonable and functional of what these things are supposed to do, is that the pipe might have a fluid category in it, which is obviously wastewater from toilets, or it could be from labs, and that's got a different functional requirement to a pipe that's maybe carrying chilled or heating water through a building.
True.
There might be different insulants on them for thermal properties. Part L might come into it again. So you've got to work out all those bits first and actually have an idea of what these things are actually there to do originally before you get to say a substrate in a building. Then you know, if you go to one of the great, passive fire seal companies that are out there, the guys that help put this together, they will be able to give you generally a solution to make it work. But if you haven't got that information, then there's a good chance they may get it wrong, because the information is not maybe presented in a way where they can go, I know functionally everything you want is in the right order, if that makes sense. They're not the mechanical designer of the system. They can't be responsible for that part, if that makes sense. They can be responsible and accountable for maybe putting their system to what you've got. And sometimes they may come back and say, actually, I can't give you what you want because this pipe's too big, or that ventilation device damper can't be in that hole, it's got to be separate. Or it could be saying you've got a buzz bar and that's got to come out and the flue can't go in, that's got to go in a separate hole as well. But all those different products have got their own little rules of engagement about how they're tested, because they all perform a different function, if that makes sense. Some does ventilation, some's doing heating, some's doing rainwater, somebody's carrying electricity, if that makes sense, and somebody's carrying flue gases. They're going to be treated differently, and that's what the European standards did, where the British ones never really did it to that degree. These ones have general rules of engagement, even down to how you put the seals in, who's appropriate to put the seal in as well for fire, and actually who's appropriate to actually say it's the right function for where I'm putting it and it's going to operate correctly, if that makes sense. It's very confusing, isn't it?
Yeah, but you're doing a good job of explaining it.
I'm trying. I'm sure I'll get the criticism later. But,
Thank you, Paul. Okay, just one thing I'm a bit confused about. You're talking about all these different products that have their own rules of engagement, as you put it, and kind of, like best practice, I suppose, for each of those things. Who's responsible for making sure, like checking the standards, making sure that each of those things is working as it should, and then also together as a system working? Do you get where I'm going with this?
Do you know what? Look, I think this is always a very hard one to answer, because if you look through people's lenses, you have people that, and I mean this in the right context, you have people that look at it and go, well, I think maybe some of this is an architect, some of this is a building, some of this is a fire engineer.
Exactly.
Or actually this could be someone who's specialist in the market. And I think the hard bit with this really is that when you look at the products and the function of them, someone's got to design that product. And where it becomes very hard is that, you look at doors, it's probably a good example. And there's a great guy out there who works at the Institute of Architectural Ironmongery that's very good at this, and he always says, when is a door not a door? And he'll go, when it's a fire door. I'm stealing a bit of his thunder here, because he's right. He's absolutely spot on how he describes this. To me, it really makes sense. When it's a security door, when it's a final exit door, well, it's got powered operation on it. That's the function of the door, but it's also going to do fire. So you've got to understand the whole function of it. So when you look at the actors in that particular instance, some of that function might be Part M for access for people that unfortunately can't push the door. That might be wheelchair bound. They might have limbs and things that that have problems with movement. You have security function. You're not anyone just walking in. And all these things have got to talk, but it might also be an exit door in such a way you've got to be able to crash through it. Then it is a fire door. So you've got to get all those functions right first. So there's someone that does security for the building. There's someone that understands design and access. There's someone that understands the product range of what you can do with the ironmongery. Then you've got someone that actually understands that it needs to be this resistance and the durability must be this durability for that period of time. Someone's got to pull all of that together. And that's 3 or 4 different competency sets.
Exactly, yeah. It just seems like it's like the areas of expertise of different people. So how do you then work together to make sure it's ticking all the right boxes? Do you know what I mean? It's
all got to be about collaboration. But it's also got to be about having the right actors in the space at the right time. If that makes sense. Because it's really hard. You can't guess it. You've actually got to be specific with it now. That's the reinforcement. So you've got to be able to say, actually, I got to that final door in that order because of all of these things is what the function was, and this is all the things I tested to. This is how it's classified, and actually it works in the support and construction it's within. It could be a rigid wall is required, not a flexible wall. And that's got to be known pretty soon by getting to the product that can do it. You may actually find there's not a product that does what you require. Does that make sense? Then you've got to go, oh, I need to do some R&D. See what I'm saying? So you can't just assume it's there. It's always, you have to be thorough enough to understand that what we want actually exists. Because otherwise, if it doesn't exist, then actually we find later on down the line that is the problem. Yeah. It's not very easy to correct it if the walls are built and the building's flying up. So we've got to get to a point where actually this is done early enough that we know that functional requirement works. That's really covered in the high-risk building regulations as well, over Gateway 2, about getting to that point. And the same thing goes for ventilation devices as well. You've got some that are motorised, some that are non-motorised. And ones that are motorised do low leakage for smoke. So if you've got, I suppose you could say, if you've got a real risk of smoke spread through your building because you've got sleeping risk, the main ventilation system probably needs the ones that motorised shut on a fire activation to prevent smoke going through it. But if you haven't got to that design decision early enough, then you may have a damper which is on a fusible link, which is all open up so all the air can go through it, to find you're putting a thing with blades in it later on and your duct's now this big when it was that big. So you've affected your part F and your part L. Just getting to that point early enough that you actually know what it is and how it's tested and how it's approached. It's really a reinforcement regulation 7. And this is where they're talking about these products in general safe terms and in safety critical. Because the ones I'm describing, I think they must be safety critical. Because they've got fire involved, they've got access, they've got, ventilation involved. It's all there in front of us, if that makes sense.
Yeah. Okay, Paul, you keep using the word safety critical. And this has been defined in the regulations, but we haven't been given a list or anything of products that are safety critical. What do we actually know about this term, what it means? And I don't know. Tell me about it.
I can tell you what I know. Right?
Tell me what you know.
And I'm not saying this is the whole truth, but I'm looking at it from a different couple of perspectives here, because you say there's not a list. And I think because CPR has a product grouping of 35 areas, I think one of those areas is 35, which relates to fire penetrations and those kind of elements. Number 10 might be smoke control, from memory. And I think you've got fixings of 33, right? So you look at it and you go, if you take a penetration seal around a pipe, that's probably a safety critical element, because if it doesn't work, you're going to have fire spread between one place to another. Mm-hmm. And also, you might have insulation on the pipe around that seal, which forms the insulation part, not just for thermal properties. Mm-hmm. We're going back to these things about purpose of what the material was there for originally. You might not put insulation on a soil pipe, but you may put it on a rainwater pipe. But you may need it on the soil pipe because it's made of steel for the insulation criteria of that penetration seal. So that becomes safety critical as a set element, because it's part of that system, if that makes sense. There's other ones as well, and I think some of the ones that are very tricky to answer, because you've got general safe products that have been around since 2005. And even for me, going through that probably quite recently, just to refresh, because you don't look at these things every day. I'm sure we don't all go to bed and go, do you know what, my read tonight is general product safety. We don't do that, do we? We learn these things and we have to go back and refresh. Continual professional development of yourself, you have to do it. Then you look at what it says about safety critical and the new regulations and safe products, and that's kind of, the safe products is a bit of a reinforcement of general product safety anyway. I think it's being reinforced again, that buzzword, I think. But safety critical is something that can cause, death and some severe problems if it's not doing what it should do. So if you look at examples and you go, what I've mentioned recently, and people know this, what I've worked with, I've said, well, if you get a cooker in a student room and it's by your door, you probably need to do something to suppress it if it goes wrong. You might have a gas unit or a sprinkler, and you might have something that cuts the power off to minimise the risk of you going past it if it is on fire. But if it's not in that same space and it's elsewhere, then it's probably not a safety critical element. Or you could say the bits that put the fire out of the safety critical elements. Okay.
Sorry, can I just ask, for example, from what I know, anchors, anchors that you fix into substrate.
Yeah, seen a few of those.
Is that not considered a safety critical installation?
My own view at the moment, this is not to say this is the whole industry view yet, because I think when you look at that list I said earlier about safety critical products, and you talk about CPR and the product list, you sit there and you go, well, 33 is fixings, now I'm doing a penetration seal on a pipe which may sit under grouping 35. That big steel pipe, either side as it goes through a wall, may have drop rods and anchors. And if that anchor fails, the pipe's coming out the wall. And so is the penetration still with it. So in that systematic approach there, it's got to be a safety critical element. Even though it's a different product grouping, it's still related to a system of products, if that makes sense.
So the reason I'm having trouble with this is because anchors, their purpose is not to like save a life or anything like that. Like it's not directly related to death, right? But if it fails, then it can lead to death. The same way a lift, if it fails, can lead to death. This is where the confusion is coming from.
And I think that's the confusion for everyone. But if you take anchors and you make it a fantastic point here, who's to say safety critical is just about fire? So if it fails and the whole big pipework assembly comes down, whoever's underneath that assembly is likely to get severely hurt or even killed. So that's the thing with anchors. And there's different. I'm not an expert on anchors. I'd go to my friends for that. Get my advice from them. There's different anchors for different concrete, and you even look at it and you say, well, even in a static state, non-fire, you might have to change that anchor probably in a fire state. But that will probably depend what that service is supporting, what it sits below it, because you could have loads of really big life safety equipment, power cables all running through a room, all this big steel pipework sitting above it going elsewhere. That probably needs to be held in place for a long period of time, because it can't fail in such an extent that you've lost your primary or secondary power supply in the fire. So there's going to be, this is why it's so hard for people to unpick it. Because it's not just something you can go, I'm just going to do a list and there you go. You've actually got to look at it in the context of where it's being used as well. And that's the real hard bit. And even with things like lifts, it's very hard because lifts are VN81. And I can tell you from experience, you try and have someone you work with and you want to put anything through a lift room or a shaft that is not related to the lift, you ain't getting it in there. Because these things are so well tightened up on how they're tested, certified. I think they've been probably, in my mind, got to a point where the risk of harm for them is so low that in reasonable use it's probably unlikely to happen. But the minute you make that lift that is something someone needs to use in the evacuation of a fire, maybe you've then spun it into a safety critical element.
I see, okay. So I guess when we're talking about anchors, this is just an example, but the anchor itself is not necessarily safety critical, but it's the installation, because that involves an installer who then needs to be competent. But then, like if we're comparing to a lift, for example, the lift has already been built and it's in the building and it's been made sure that it's good to go, if you get what I mean. So there's no added element that can lead to the safety. Is this? Am I getting the idea?
No, this is a common conversation at the moment, and I don't have all the answers, by the way.
Okay.
But I think I'm just going to try and give some very impartial views from my own mind. Okay. So you've got two scenarios there. You've got one where you might have fixings for pipework, and there's still a design element. It's got to be able to take the load of that system it's holding. Someone needs to have actually got to the point of actually, will it stay in that substrate and hold that load?
Exactly, yeah.
Is it the right depth? Is it the right gauge? Is it the right material? And I think from memory, and I say I'm not an expert at this, I'd go to dear friends of mine for this, but there's different colours. One is an appropriately ETA'd one. One is like a goldy colour, is probably not. That's just from memory. So you look at it and you go, that's a safety critical, in my view, anchor that's holding stuff in the air. And it's not just MEP here though, is it? If you take the lift, and it's in a concrete shaft, it's going to have anchors into the concrete. Someone's got to assess those as well. It's got to be the same process, if that makes sense. It's got to be the same process to say that is the right anchor and torque. I'm sure they've got to be torqued up for where you're putting them. Because I'm sure if you over torque these things, like I've done it in the good old days when we could service our own cars, for those that remember, you could get your gun out and watch the flywheel go around. You could over tighten stuff and snap it off and go, what am I going to do now? Because you can over torque it. So there's got to be a way of doing that, if that makes sense.
Okay. Well, thank you, Paul. I think let's move on from this question because we could talk for ages.
Oh, we could, yeah. It's a difficult one.
So, Paul, just to go back to something that we touched on earlier about adopting a product system mindset rather than commodity item, separate item mindset. What do you think are the kind of obstacles that we have to go through and the complications in adopting this mindset as an industry? Because it seems like a big change, No,
I think it is. I think if you go back to the beginning part, we're talking about the original building regulations, and I think it's really prevalent because I kind of feel that if we have a good knowledge as individuals, and it's good for all to, as I said earlier, we have to refresh. We have to go back sometimes and read things and go, has my view since the first time I read it in my career changed? And actually, has the BSA, actually the Building Safety Act, affected my view of what I thought? Because the way things have been rewritten, it kind of puts sometimes a different spin on how you look at it. So I've sort of looked at it and said, well, every building that we construct has a purpose group, right, in fire safety terms. And purpose groups are there because different buildings, you could say, hold different risks, if that makes sense. Yeah. There's probably overlapping a bit with some products being maybe critical in one, maybe on another use. And what those ones are, as I say, I don't know yet, but when I know, you'll be the first to know, my friend there. So look, you sit there and you go, if you look at purpose groups and you start looking at space risk, because if the space risk in a purpose group of a building varies, then the products that meet a space risk in, say, a hospital for a certain part of it, you could say you might have a storeroom full of bandages and you go, well, I've got a ventilation duct feeding it in a door. And you might say, well, that door actually, because of the way maybe the great documents like the HTMs or HBNs are written, and I'm not saying this is factually true because I need to refresh myself on those, you know. But you sit there and you go, well, maybe you want the door to have low leakage for smoke. If it's the fire in there, you don't want smoke getting out because you've got people in states that you can't just move them. Just putting in a bit of logic in my own mind. And you go, well, you might actually want a vision panel so you can see what's actually happening in there rather than opening the door to find out. And you certainly don't want the fire breaking out. And you might want the door to have insulation because you might have lots of things really close to it, not a lot of wall area, so the door doesn't spread fire by radiance. But if you take the same store and you put it in maybe a general office building where you have an evacuation strategy where people aren't left in place like you might have in hospitals, you might say in that room there, it just needs to protect against the spread of fire. The smoke risk and the other ones don't come into it.
Yeah.
So it's very specific, and he's probably touching on competency and, you know, again, really, and I think that's one of the words that everyone uses it, and there's a bit of cliche around it, but you sit there and you go, well, you can't just put your mindset on that condition. You've got to look at the different purpose group and the different space risk and say, is what I've done there now still applicable to that one? And actually, if you don't go through that rigour and everything that you look at, you'll never know. You can't just assume it, and I think that's part of that reinforcement which we all need to get. Even me, we need to get better at making sure we go through those logical steps. And it's the same for that ventilation system. It could be in that particular space, they're all motorised shut instantly because of the risk of spread for the ventilation system and pathogen control, you know. But you then go into the other store and you might say, well, it's just integrity. Everyone's gone anyway. That makes sense. It could be a different classification of equipment to meet the same potentially space risk, but the space risk isn't it's the effect of that risk if it goes wrong on the surrounding element of the occupants of the building. That makes sense. I'm trying to explain it in a way where I think people can process it a bit easier. That makes sense.
So once you have identified the risks, what are the next steps? What do you do with them?
What do you do with it? And that's the real hard bit. Somehow you've got to sit there and look at all these different products, and it is really confusing. So I'm going to try and explain it the best way I can here. So you'll sit there and you go, I've got many different space risks in that purpose group of building. And you'll sit there and go, well, some of those risks of the space spreading from one to the other is actually a risk to the people, the occupants, as I said earlier. So some buildings you may say, well, actually, I want to keep people in place because it's safer to do that than try and throw them all out for a staircase. I might have a space for a big enough staircase to get them down. So I might hold people back before I release them. And that can affect the classification of all of these ventilation devices and walls and risers and what you put smoke leakage into. Because it's the smoke that's the risk there as well, is that the smoke's going to cause problems before the fire ever breaks through. Once you've got all of that information, you've got to sit there and go, well, all these products can do different functions against that risk or can protect against it. So you've actually got to sit there and go, things like pipe work, ventilation, fire-resistant ducts if you've got kitchen extracts in the building, smoke control systems like you might have in your staircases for fire brigade use, or you could have pressurisation. All of these things are going to be classified differently depending on those risks. So once you know what the risk on the space is and how the people in the building are going to stay or go and all the other potential risks within it, you can look at how all this kit operates. As I said, security door, open, shut, all these other functions, and you can classify it. But you can't just do it in a general way where you go, I'm going to put everything that's fire into one place and think it's all the same, because it's not. How you classify pipe work And pipes through walls are horizontally classified. They've got a H number in the classification. Whereas a ventilation duct is a V, because it's dampers this way in the wall. They're doing different functions. So you've got to get those numbers driven out, because when you look at it and you go to the next stage and you go, now I've classified it, I need to make sure actually the wall that they go in, because during they're either in walls or floors, and hopefully this is working, right? Because I know how complicated some of this stuff is. You can go, does that wall, the type of wall, is it concrete or is it brick and block or is it a symmetrical drywall? Do all of those different classified products work with the wall I think I've got? For thickness, for density, because if you make drywall too thick, you can have problems with pipework seals because you can't always thicken bats up. If you make them too thick as well, the ventilation duct dampers you may be wanting to use, the fire dampers, the connections might be in the wall. You can't attach a breakaway joint. So you've got all these things that have got to come into that bit of coordination there. But once you know the classification, you can talk to manufacturers who can say, do you know what? Over here, I can give you something that meets that classification. What they can't do is say, all of your products together are going to work on that wall. That's the skill set that someone's got to be able to pull together. And I think the collaboration I mentioned earlier is getting everyone together to actually say, I'm competent on this product, I'm competent on this, I'm competent on the wall. You put it all together, and actually, I've got a schedule of all the components in that wall with a wall type that meets that classification. And that's the bit we've got to get to. But the last bit, not to really drag this out, is that you've actually still got to be able to install it. There's no good giving a spatial requirement somewhere where the person that's got to install this, because it's CDM and safety as well, it's all the other aspects of legislation, has got to be able to get in there, appropriately apply that, going back to that Regulation 7 piece again in a workmanlike manner, those seals. They've got to be able to do it. And they've got to be able to get in there for future maintenance to make sure things haven't deteriorated, nothing's broken. If we don't look at those sort of 5 initial steps about how you get to the adequate and appropriate for the function, then that's where we're going to get ourselves into a bit of trouble with it. And that's the bit that's been very hard to get everyone to do, because the products themselves are all so complicated. And as we mentioned, I think, trying to simplify things, but I don't think you can necessarily simplify the test standard, because the test standard is there in such a way that it does the function the kit is supposed to do. I think we've got to simplify how people get to the right decision. That's the bit I think we've got to help everyone do.
Yeah, and like you said, I guess that's where the competency comes in as well. And the importance of everyone doing their job needs to be competent at it. But like you said, it's kind of a cliche term now. It's being thrown around a lot. Even we use it a lot. And there's also some confusion in the difference between compliance and competence. What can you tell me about that in your words?
Well, what I would say is that I try not to use the word competency or competent.
You use it many times.
I know I have in this. I know. No, I stand corrected. Okay, look. I think just to probably add to this a little bit as well is that when you look at competency, as I said earlier, I've been correcting myself for using it too much. You can, as I said about the wall system, maybe I'm competent to a degree to get to the right level of what goes in that wall, different product-wise. But as I said, I have to rely on other actors to help with certain parts of it, which is knowing the limits of your own competency with it, which I think we all need to recognise. But it doesn't necessarily mean once I've got to what I believe is the whole system, whether it's ducts, dampers, all this other kit that goes into that wall, and I'm not competent yet to do fire doors, nowhere near it. I rely on other people for that because they are really complicated. I haven't got to that subject yet. Because the doors, don't forget, it's not just MEP, that this is one of the biggest things. You might have a glass screen in there, a fire door, there might be other things like steel beams going through that you need to encapsulate or do something else with. That's all part of that wall system. And, funny enough, this will make you laugh, you've got to have enough wall left at the end of it that it can stand up in its own right. I think that's a given, I want to say. The wall's got to be able to sit there, not fall over as well. But it doesn't mean I'm competent to go on site and actually say everything that is there is installed absolutely correct. Every screw, every nut, every bolt. That's a different skill set. Getting to the right product and product set is one thing. Making sure they're installed appropriately is another skill set, if that makes sense.
Okay, so this is where I guess the definition I think it's in the Building Safety Act, is where it says competence is not just the knowledge, but skills, knowledge, experience, and behavior. Yeah. So a lot of people think, oh, I've done this for a long time, meaning I have the experience, that means I'm competent. But no, because you need to also have all this other.
Behaviour is the biggest one for me is behaviour, I think, really. And you look at it, you've got to know the limit of your own competency. So you might have a situation, you see this often, where you have a manufacturer that might do penetration seals around pipes, because I think the word fire stopper, and I've said this many times to my industry friends, is I'm not very keen on the word, because everyone assumes it covers dampers, ducts, flues. It's a different subject, it's a different level of, it's a different piece of kit. So you look at pipework and you go, the great companies that make these seals, sometimes what's happened in the past is you may give them a hole where actually it's not anywhere near what's been tested in relation to the size of the hole or the depth of the wall. And sometimes they may be able to help and say, well, actually, if it is the same type of wall, we've got evidence that says we might be able to go a bit closer than that, actually. But they can't help you if there's something wrong with the wall, the aperture framing's wrong, the depth, all the other things that come into it. That evidence for how that works and performs is someone else. So it's understanding the limitations of your own competency around it and saying, well, I can't keep going at them to give me something which maybe is not in their gift to do it. In the same way that, if you look at what's happened with fire dampers, we might be going on about people have mechanically fixed ducts to dampers and they should break away, but we can't miss the point when we look at it and say, actually, is it the right damper for the space we put what's there? Is it actually installed correctly to meet that function as well? Does it make sense? You've got different levels there, and on behaviour, it's understanding actually, we can't know it all, we don't know it all, and when we don't know it all, we've got to find people that we believe are competent that do know and try and bring it together. And we'll always make errors in these, because it's not always very easy to get to that appropriate system. The main thing is, I think, if you all go together at it and you come together, you collaborate, then it's a bit easier to get there as a collaboration of people, rather than trying to think one individual can do it on their own, because they can't, if that makes sense.
And how does that differ from compliance, in your opinion?
Oh, compliance is easy, isn't it? You just say, is that compliant? And someone will say, yeah, I think it is. But I think compliance is another word which is very, very hard, isn't it? Because when you ask someone, you've got to look at this in all the different wording that's there. And hopefully I'm going to get this right. I'm going to try and do this best I can. Is that when you say to someone, is it compliant? You're saying to them, is it a reasonable level of safety and health for people amongst the buildings who are affected by it? Is it adequately supplied with mix? Is it appropriate for the circumstances? Is it appropriate for the function it should perform? You're asking such a broad bandwidth of things there.
But also, is it meeting...
In one word.
Yeah, and also is it meeting standard requirements, Building Safety Act requirements, any legislation?
The bandwidth just going
So I guess that's where it's a bit difficult to pinpoint exactly what you have to be compliant with, I guess.
I think it's not hard in the fact that if you look at that Regulation 7 you said at the start, if you can answer that test, I think in your own mind that actually, or as a group of minds, more minds are better than one mind, I can assure you, in the industry. You get to a point and you say, actually, I know it's actually appropriate for that function, because we know the risk of that space, we know how it's supposed to operate, we know how people are getting outside the building. Actually, we've had a management plan for this high-risk building that tells us how we want to manage it at the end. We've fed that into the strategy at the start. All of these things will come together that you'll know I've got products that meet this management strategy, because how I'm doing smoke control, how I'm doing detection. You can bridge it out, but by saying is it compliant, it's a case of has all that been gone through is the fundamental part.
Yeah.
You can't just look at it and say, is that pipe compliant? You might have 25 pipes on the wall, loads of train, you go, is that compliant? Can you imagine how many bits you've got to go through? Is it functionally requirement for the pipe itself? Is the insulation there for firmware? Is it all that right to go, actually, is the hole the right size and the spacing's correct? That's actually what someone is asking, and it's not really as simple as going,
it's a lot.
That's just a yes or no answer, isn't it? It's not.
That's interesting. Thank you, Paul. Okay, so transitioning from that, speaking of compliance, the current regulations and the whole shift focuses a lot on the need for evidence. So, first of all, why do you think that is, and why now?
I think, look, if we go back, probably over the last, because I can only talk about how long I've actually been in the industry for, and actually in a position where I've handled information in construction. So I think when you look at what's been built previously and how those products have got there, the hard thing is actually do we know previously what's been constructed, that the product that's been installed was actually correct in the first instance? And you see a lot of this that goes on, and you hear about things where you go into a building and you go, well, actually, I'm not too sure if any of this stuff is completely correct. And you can't just look at things and go, because it looks like it's been maybe installed not with the right workmanship, that it's incorrect. It could be fine. You could have stuff that looks absolutely beautiful, but actually that's not fine. Yeah. Just because it's neat and tidy doesn't mean it's correct. So we've got to get to this world where actually we say, and this is all off the back of Grenfell as well, because so many things, unfortunately, and it is tragedy, that just didn't function, that we've got to get to the point that we know how these things are there and what they're actually functioning there to do. So you actually need a record of actually probably why you use the product, and that's probably a summation of how the building's supposed to be managed in its final state, probably the work you've done at Gateway 1, that bit's got an operational management strategy, because that will affect the products you need and how they operate to meet that functional management strategy in fire, egress of people, smoke control, evacuation strategy. You can't, if you haven't got that right at the beginning, because you know how it's working at the end, you might find you've got the wrong classification of fire dampers in a building to prevent the spread of smoke, when actually you needed them to do that because you didn't know at the start the building was going to be simultaneously evacuated, or it was going to be simultaneous, but it needed to be phased evacuated, if that makes sense. You need to know how it's going to operate. So you need the evidence to how you've made that decision to get to the product tree in the first place. So the evidence is really, once you've got to that point, as we kind of said earlier, then you can look at the risks of all the spaces, how these things operate, and you just got to, use the word thread, it's a big thing, golden thread, but how you get to that selection of kit, then prove it as a system. And not forgetting that once you know the products and the systems of products, most of these things are going to end up in a wall. It's probably best to go for the wall last, not first, but that's something that I think will change as time goes on. Then you've got to know how that's passed over, so that whoever's doing a safety case can just pick it up and go, there's my decision tree, there's the evidence of how I've got to there. Because if you're in a building which is 20, 30, maybe 15, even could be 10 years old, and you're trying to do a safety case, you've got to try and work all of this out. It's not going to be very easy, is it? And it's probably a bit unfair, isn't it, as well? Because you sort of go, seeing how complicated these products are, you've got to try and work it out. It's very, very difficult.
Okay, well, in the process of gathering all this evidence, how can M&E contractors, or just contractors in general, ensure that they're not recording their own, I guess, self-incrimination, that they're doing something wrong?
Oh, that's a great question. And I think if you look at what I've just sort of said around, the product trees here, it's a bit like, if you know how you've got to that product based upon the risk of the building, the purpose group, and you've recorded it out, then you've done the first part of actually quality assuring, actually that design is correct. And it works with all the other products, it's an assurance piece. Yeah. If you go to a manufacturer, because not saying this is all the manufacturers or it isn't the manufacturers, because I haven't got the breadth of knowledge of all the different products that are made to say they're either producing the right kit to meet requirements in buildings or they're not. Or over the ones that I deal with, which is in smoke control market, fire dampers, and I mean these guys in these markets, even on pipework seals, I mean the work that is going on in collaboration, they should all be applauded with it. They are doing such a fantastic job of actually saying this is what my product does and this is where it's probably applicable to use it. But you've got to remember, they're not fire safety experts, and neither am I really. These guys aren't, definitely not. What they can do is give you a product. If you don't know the key code for what you wanted, and you go to these guys and you say, just give me a fire damper, and they go, is that what you want? And you go, I'll have that. That's what you wanted. I don't think they're not necessarily going to give you something which is unsafe, but where you use it might make it unsafe, if that makes sense.
Yeah, that makes sense.
There's got to be a better way of actually saying, and there's some great things, there's CCPR that's come out, which is about declaring information better, and that's going to be a great thing, by the way. But one thing is that it may declare the information right, but you've still got to have that competency of actually, is that applicable to that risk of building and circumstance where I'm putting, and does it work as a system? It's going to help, but it's not going to completely nail that bit down. That's the bit that's the really hard bit to get right, if that makes sense.
Yeah, that makes sense. Tell me more about the CCPR, Declaration of Information, that you were just talking about.
You were talking about Declaration of Performance. Yes,
oh.
Yes, so I said CCPI is it's a code of practice for better product information, which is done by the CPA. So that's the whole subject in its own right. But it's it's a great thing that's come out, and I think manufacturers will sign up to it. And I think it's a good thing. And not that I'm an expert in every part of it, because I'm not. I've read through it all, and I've seen things that are said in it. It's going to enable manufacturers to declare what their product does in a better format, and it actually helps them to question, actually, what does my product actually do, if that makes sense. It's a good thing. When it comes down, I think you said declaration of performance there. This is the real hard bit, and this is where CPI I think is going to reinforce this, is that you may declare certain aspects of performance of a product. So if you're trying to get a fire damper to meet a space risk, they might declare, well, my damper's got an integrity resistance of 120 minutes to flaming. It might do leakage of smoke for 120 minutes. You know, it's not preventing smoke, it's just a lower leakage rate, and it's tested both ways round. And actually, it might actually have a classification for resilience. We mustn't forget resilience in this as well. Most products have a reliability factor. It might be a C10,000, open and shut 10,000 times. You know, actually, it can be open and shut once a week on a fire alarm test, and it's not going to fall apart 2 weeks later. These things exist. But there's other things there which aren't part of the declaration of performance. Maybe like the thickness of the wall, the infill of the material that's used, the type of screw. You know, that comes in a different package. If that makes sense. So you've got to be able to pull all of that together to understand. You might get to the appropriate function, but it's got to be appropriate for where you're putting it as well. If that kind of fills together.
Yeah.
Make sure I'm explaining it correctly.
Thank you. So I just want to touch on something quickly, Paul. When we're talking about evidence and an appropriate system, and what you were just saying, how can contractors make sure that they're being vigilant about misleading claims and, I guess, misinformation? Because you don't have to look too far to find that some manufacturers are claiming that they have certain evidence behind their products, or that their products, are, for example, fire rated or something, and but without the evidence to prove that. So yeah, how can we just be more vigilant about that?
I think there's probably a few different things in there. You kind of saying. I think if you look at the misleading of language is the hard bit. I think because. There was a really good piece of, not sorry to mention the CPA again, because I'm a big fan of theirs and I can't help it. There's some really good people that I communicate with. You've got to look that there was, claims that my product is fireproof, and you go, well, what does that mean? Because actually,
fireproof is the big.
I know, because I'm fireproof to about 40 degrees C, and after that, I'm not fireproof. If that makes sense. So that's a bit misleading, isn't it, in its own right? So I think we have to get the language right, and I think the CCPI does a lot of that, I think, if not all of it. So as I say, I can't comment too much because the CPA might say to me, Paul, you're saying the wrong thing here. And I don't want to say the wrong thing, if that makes sense, because they've done such a fantastic piece of work with this. And as I said, everyone's going to benefit. I think they will cover a lot of that. I think the hard bit is, and I think it all comes down to your original point at the start about Regulation 7, which is fantastic. And I'm like, it even goes on about competency and compliance. But Regulation 7 is the thing that I'm always telling people, Regulation 7. I can't see anything else but that. So if you go to a manufacturer, as I said earlier, and you go, I want a fire damper, and actually I've got a specification from a consultant, but maybe that consultant's probably feeling the same as this person that's going to manufacture, doesn't really know how to get to an appropriate classification for that product because they're not an expert on the fire element. And actually, you could be the fire engineer doesn't really know what that product does, because I'm not sure that fire engineers go down to labs and test products with damper manufacturers, and I don't think that's where they are. It's about overall strategy and, policies of fire and the building, and they're really clever in that element. But I'm saying that they're the best people for products. That's a different skill set. So unless you get everyone together at the start to actually clarify what that product's supposed to do for that risk and building in space, you could go to a manufacturer and actually, not just about misleading claims, it could be actually you're misleading yourself in the question you're asking. So everyone needs a bit of help with this. Does that make sense? So, there's a manufacturer saying, my piece of kit can survive for 45 years in a fire at this resistance, just being over-exaggerating here a little bit, when actually the reality is it does 120 minutes, But there could be a misleading claim where someone says, I've got a motorised piece of fire equipment that opens and shuts like a damper, but it hasn't got the resilience for testing, so it hasn't been cycle tested. So if you're testing it once a week in a building, it may be that after it's open and shut so many times, actually, it's not really appropriate for that circumstance anymore. Does that make sense? It's a bit like going to a wall manufacturer, this is probably a really good one, and saying, I want a 120-minute fire-rated wall in my basement corridor. And it's all the bins are going through. But actually what you wanted was a wall with good mechanical impact as well, because once the bin's a bit at 16 or 17 times, the wall's never going to perform anyway, is it? Does that make sense? You've got to look at it from both people's eyes and say, if you ask for the information in the right order, you'll get the right response. It's the validation of actually, is it what you wanted that's appropriate to that first of all? Then they can say, I can either do it or I can't. It enables you then to question it, if that makes sense.
Yeah, thank you. Okay, so on that point, fire safety is kind of a big concern for a lot of people in the sector now. So what kind of questions should they be asking? What should they be looking for? Because you hear things like, first of all, what's the difference between fire tested, fire rated? Is there something that you can actually claim is fire rated? Like, do you know what I mean? Like,
no, I do. It's really it's the language piece, isn't it?
Yeah.
I mean, look, everything has a performance to something in the way the European and British standards have been adopted together. So if you took fire-resistant ducts, that's what it's called. It's not called fireproof ducts or fire-rated ducts. It's fire-resistant ducts is that standard. That will give you resistance to integrity, insulation, and it will give it to leakage of smoke as well, from both inside the duct where the fire is and maybe a kitchen extract and outside. And by default, the way they do it, you test the seal at the same time. But if it was smoke control duct, it has a resistance as well to cross-sectional area loss. So if you've got a duct that's conveying hot smoke, there's no point in crumpling up, is it? Because the smoke ain't going out. So there's criteria where you can't lose more than 10% of your cross-sectional area. That's the resistance. That's what that one there is. It's not fire rate, it's a resistance. Nothing ever stops everything perfectly. It resists it, if that makes sense. And there's criteria to how you fail that resistance. Reaction to fire is a different thing. And this is where it becomes even harder, is that some things you test for resistance, it's not prevalent on its reaction to fire. So if I test a fire damper in a wall, it's preventing hot gases and smoke. It's resisting, not preventing. See, my language is not good there. Going from one side to the other, or vice versa. But its reaction to fire, if it didn't react to fire in a way where it burnt, it makes sense, you couldn't use it as a fire damper, could you anyway? But if you put pipework in and it's made of polyethylene insulation, it's got HDPs or something else on it that's is quite combustible, maybe I can't put that pipe in the space, because actually if there was a problem, that's adding to the fire load in such a way it makes it dangerous to put it in there. So you've got to look at all that, though. You've got to get that language right depending on what you're looking and where you're putting it. That's the real hard bit, isn't it? Because there's lots of different terms that get used.
Yeah. So obviously we're in the M&E sector, and we often get asked about the fire performance of products. What is, saying everything you've just said, what's the appropriate way for a product or a system to be evidenced in terms of its fire resistance or fire performance? Because like you said, different manufacturers kind of perform their own tests, and there's not one set way to do it, if you know what I mean. So
I think, when you look at, and I'll just go back to the examples we've used earlier, is that if you take a system like a sprinkler system, it could be a fire-resistant dust smoke control system. It could even be fire dampers if they've got support fixings, or it could be smoke control dampers that are in ducts with their own support fixings. All of these different systems are classified differently, so that the trick with this is, to evidence it, is to make sure you've got provenance of how you've got to the classification of what that function is, because things like smoke control dampers can be automatically, just automatic systems where you have a fire, they open, and you've got no buttons, it's going to do what it's going to do. But sometimes you may have a situation where the system needs some intervention. And if it needs intervention, because it could be that you've got 10 fire zones and a smoke zone because of the limitations and sizes of basements, where you go, well, actually, if there's ever a problem, if you think about that, fan doesn't start, or it for some reason it goes horrifically wrong 20 minutes into a fire, I want to shut all those dampers back down again. I want to compartment the rooms, because compartmentation's got to take presidency in that instance. That system becomes basically a manual intervention system. It becomes an MA class. So unless you've gone through these operational things and said all you can't get to those numbers. But what you've got to do is when you do get to those numbers is schedule it out differently. Don't put everything in the same place. Make sure you have all the products scheduled by what they're supposed to do, where they're located. The common bit I think is to say they're all located in these walls, all these different products, by one common schedule. But you've got to have a schedule that then goes back to actually what the function of those products were doing. Otherwise you can't monitor the traceability of it. Because if you know what the products were, how they operated, what their function was, if anything goes wrong in the future, like we said, sort of mentioned earlier about traceability, is that you know the manufacturer, you know the serial number, you know the batch number, you can put that in software in things like BIM, you can trace that product as well. It's harder with things like walls because walls come in big pallets, don't they? And you're going to break them up and you're going to send them off. It's a bit harder to do the traceability though, but you have batches of what's been sent. These things like control dampers and many component parts, the wall is gypsum plaster, not taking anything away from it. But you still might have things that go wrong, if that makes sense. But you've got to schedule them out slightly differently.
Okay, thank you so much, Paul. I feel like I learned so much. I'm going to have to rewatch this episode a few times, I think, to fully understand everything. But so I normally ask all our guests at the end of the episodes, if there was only one thing you could change about the industry today, what would it be?
That's one you put people on the spot with. I like it. I think the first thing is, I'm going to answer your question, because I think with some of the questions today, it's very hard to give you a specific answer because of the complications around it. So I think the first thing is, for me, is that construction's great. I love construction. Wouldn't change a thing in how I've got into it, put it that way. I think it's been a very good journey for me. So one of the big things is making sure that other people realise how good construction is. It's a good place. The bit I would probably change is try to change people's perceptions of it. Because I think when you get bad press around things that have gone wrong, everyone automatically assumes that, I'm not saying this is true or not, but I get the gut feeling that people think everything's just not good. And actually things are good. There's some very, very good people, there's some very good businesses in this. I mean, like I said earlier, is that if you look at the collaboration that's gone on, because my knowledge has gone up massively, to be quite frank, because of the damper companies, because of great people in the ASFP, individuals that do their own companies on smoke control. These guys have really helped me, and even people in the wall industry like the FIS, the collaboration that's gone of all these different people, and even the tier 1 contractors. We had PFKG that's got together, which is a tier 1 collaboration. That is what is making it a great place, and that's the only thing I would say for me, is that we need to make sure we don't put construction down. It's a great place. Does that make sense? It's really good, sense. And for anyone that's coming into it, I think, wants to come into it, just get in there, get boots on, go away, learn, become the next generation, drive carbon, drive the fire safety. It's a great thing.
I love that. Way to end on a positive note. Thank you, Paul.
No, it is. It's good. And thanks for having us today.
Oh, thank you so much. It's honestly been so great, and I've learned a lot. And you're welcome back anytime. Oh, thank you. And I'll be sure to tag you on the post when this goes out. So thank you, Paul. Thanks, everyone, for listening. I hope you enjoyed, and I'm sure you learned a few things. Don't forget to check out our other episodes, and we will see you next time. Bye-bye.
Right.